Hello everyone. In this video I want to do a couple of sample problems out with gravity. So the first one that I'd like to go over is what is the force of gravity between Pluto and Earth? And we're given that the mass of the Earth is 6 times 10 to the 24th kilograms, the mass of Pluto is 1.3 times 10 to the 22nd kilograms, and this between the two planets is 5.76 times 10 to the 12th meters. I do realize that this is sort of an average distance. I realize it gets closer and further away, but just for the sake of purposes, I just picked a number. So, reminding you that the equation for universal gravitational, we have the force is equal to the universal gravitational constant multiplied by m1, m2, and then divided by the distance between the masses squared. And given the numbers that we have in the problem, the mass of the Earth, mass of Pluto, square the distances here, what we see is that the force of gravity between the two objects is 1.57 times 10 to the 11th newtons. Now this might seem rather large, and I guess for everyday objects that we deal with it is a rather large force, but the moon pulls on the Earth with a force on the order of magnitude of 10 to the 20th newtons. So by comparison, this force is relatively small. So the next one is calculating out the acceleration due to gravity on the surface of something other than the Earth. So we're going to do it for the moon, and we know that the mass of the moon is 7.35 times 10 to the 22nd kilograms, and it has a radius of 1.74 times 10 to the 6 meters. And we're looking to calculate the acceleration due to gravity on the surface of the object. I'll remind you that the force of gravity is m times the universal gravitational constant divided by the distance squared, and that is the same force that causes the object to accelerate. So when you make these two equations equal to each other, the mass of the object, in this case the apple, cancels out. So what we're left with is that the acceleration is equal to the universal gravitational constant multiplied by the mass of the larger object divided by the distance between the two objects squared, and because we're doing this on the surface, we will equate that with the acceleration due to gravity on the surface. So plugging in the values that we have for the moon, the universal gravitational constant, mass of the moon, radius of the moon squared, the gravitational acceleration on the surface of the moon is 1.62 meters per second squared, and I'm hoping that this is consistent with what you would have thought it should have been. It should be less, considering the moon is smaller and less massive than the Earth. And now, some ocean waves. Thanks for watching.